7.6 Practice Problems. The chemical equations and equilibrium expressions for the two reactions at the same temperature are given above. Based off of the information, which of the following expressions can be used to calculate the value of K3 for reaction 3 at the same temperature? So when we are looking at these reactions, we are going to see what direction we need them to go into in order for everything to match what we want to happen in reaction 3. So in reaction 3, we do need the CH4 to be on the reactant side, which does mean that the K1 does need to be inversed. And we also need the carbon dioxide to be on the product side, which means that K2 is also going to need to be inversed to flip their products and reactants portion. And then since both of them are inversed, we can then see that the carbon monoxide cancels out, and then we would be able to match the reaction 3 in a predicted order. So we need the inverse of K1 and K2, and the only answer choice that offers the inverse is option choice D, so that is going to be my choice. Based off of the equilibrium constants given above, which of the following gives the correct expression for the equilibrium constant for reaction 3? So again, I need to see if I need each of these in the forward or reverse reaction in order to match my final direction here. So I see that I need the HOCl3 or Cl to be on the product side, which means that I need K1 to be inversed. And then reaction 2, the water and hydroxide are on the correct sides. And once this entire reaction 1 is inversed, then the hydronium will cancel out, leaving me with the same net equation as is stated in reaction 3. So I need an inversed K1 and a just normal direction of K2. So this could be expressed as 1 over K1 times K2, or as we see written here, they have collapsed the fraction so that K2 appears on the top. But really it is the inverse of K1 multiplied by K2, giving me my equilibrium expression for K3. The table above lists the equilibrium systems and their equilibrium constants. Which of the following identifies the correct mathematical relationship that uses the information to calculate K5? So since we have so many different reactants and products and stuff, I'm going to use a highlighter to indicate whether this needs to be on the product side or a reactant side so that it matches and we can make sure to see if things are in fact canceling the way they ought to. So I can see that carbonic acid does need to be on the reactant side. So these are going to remain on the reactants, and that's going to be green for me, and my product side is going to be that pink. Reaction 2, I don't actually have any of those pieces in my entire reaction, and none of my answer choices contain reaction 2 at all. So I'm just going to go ahead and get rid of it since it is not even an answer choice that I need to deliberate about. Next up, I'm going to look and see that for reaction 3, I do need ammonia to be on the reactants side and ammonium to be on the product side. So this is going to remain in its current orientation. And then finally, I need to figure out what direction K4 needs to be in so that the net ends up being this. So currently, I am going to be left with not only the pieces of the products that I want to be left with, which are the ammonium and then the carbonic acid with one hydrogen having already dissociated off, but because the hydronium and hydroxide have not been canceled out yet, that is going to also appear. That's a problem. So I actually need reaction number 4 to be reversed so that I can have hydronium appear on the left-hand side and on the right-hand side, and hydroxide appear on the left-hand side and on the right-hand side, and my 2 waters to be canceled out. So even though K4, all of my products and reactants end up getting canceled out with the net equation of K5, this does need to be inversed. So K4 does need to be inversed, and so I could write that as K1 times K3, remember K2 disappeared, times the inverse of K4, or we can collapse it down as we see in answer choice A, and that will be my final answer. On the basis of the information above, the dissolution of iron 2 fluoride in an acidic solution is, and then I'm going to go ahead and look here. So I see that the iron 2 fluoride going to this, okay? So my K3, it does look like I am going to be able to keep everything in the current direction. I am going to multiply my total coefficients by 2 in order to get it to cancel out. However, the concentration doesn't change my K value there, but that will allow me to cancel out the fluorine that appears on both sides and have the correct net equation. So these are both the correct directions, and then I would just be dealing with if my K3 will be positive or negative. Now, I need to go ahead and figure out K3. The important thing for K3 is that we are dealing still with overall concentrations, and even though my net or my equilibrium constant value doesn't change, it is still raised to whatever coefficient I need to have it balance out. So I do need 2 of this to happen, which means that my equation is going to be K1 times K2 squared. Because again, I needed 2 of this, so I am raising it to 2. So K1 was 2e negative 6, and then I am multiplying it by 1e3, and that component is squared. And that gives me a number larger than 1 for K3. So anything that says that K3 is larger than 1 is going to be my answer choice, which is just B. And that states that it is thermodynamically favored because my equilibrium constant is greater than 1. At a certain temperature, the value of the equilibrium constant K for the reaction represented above is 2 times 10 to the 5th. What is the value of K for the reverse reaction at the same temperature? So the reverse is just going to be the inverse, so 1 over the value K, so 1 divided by the 2.0 times 10 to the 5th. So 1 divided by 2 times 10 to the 5th, and that is currently in standard notation, not scientific notation, which is how all of these are written out, but I can go ahead and get rid of anything that isn't 5 based, and then we just need to count. 1, 2, 3, 4, 5, 6. And we are smaller, so answer choice is going to be B, 5 times 10 to the negative 6th for my value of the inverse K. At equilibrium, the equilibrium constant for the gas phase reaction is above 95 at 25 degrees Celsius. What is the value for the equilibrium constant for the following reaction at 25 degrees Celsius? So here it is the inverse reaction, but it's not only the inverse reaction, but it is doubled. And so I'm going to inverse my K, and then since I have doubled my coefficients, I am going to be raising it to the power of 2. And so my K originally was 95, and so I will have 1 over 95 to the power of 2. And so that is going to be answer choice E. Given the value of the equilibrium constants K1 and K2 for the reactions represented above, what is the value for the equilibrium constant K3 for the following reaction? So I need to make sure that everything is in the appropriate direction. It looks like they already are in the appropriate direction, and I don't have any multipliers there, so I can just go ahead and say that K3 is going to be equal to K1 times K2. No need to raise either of my K's to any particular value, since I don't need to multiply the number of coefficients in order for everything to add up. So K1 was 2E105, and K2 is 7E24. We seem to be upset. Let me try this again. So 1E or 2E 105 times 7E 24. Nope, still upset. Okay, so we're gonna have to do this kind of manually. So basically, since we are multiplying, these are going to be additive there. And 2 times 7 is going to give me 14, and then E 105 plus 24, which is 129. And then to make this truly scientific notation, it would be 1E 130. And so option choice A would be my choice there.